Let's look at the difference between physical and chemical changes. Now, in order for us to compare these two, it's useful to have a look at physical properties versus chemical properties. So let's have a look at some definitions. For there to be a physical property, or for it to be a physical property, we can observe it with the senses, and this can be determined without creating or destroying what we're actually sensing. So some examples of physical properties might be melting point and boiling point. We're not actually creating or destroying the substance we're detecting. It could be something as simple as luster, or the shininess of something. It could be the hardness of something. They're all physical properties. On the other hand, if we've got a chemical property, where actually it's an indication of how a substance reacts. So we can often have this with something else, but quite often we can have a trigger and it doesn't necessarily have to be another substance. So an example would be us burning paper in air. We've actually reacted that paper with the oxygen to create a new substance. And our second point adds to that. So in the process we create a new substance. So our example with burning a piece of paper, we're creating carbon dioxide and water from oxygen and whatever our hydrocarbon source is. So let's look at some other examples. Let's say a substance has a blue colour. Now we're sensing that with our eyes. We're not actually creating or destroying whatever the substance is. Therefore it must be a physical property. On the other hand, flammability, as we said before when we're burning paper, is a chemical property because we're creating a new substance. Sour taste, we're using our senses, but we're not creating or destroying anything. We're only tasting it. Therefore, it must be a physical property. On the other hand, reacting something with water, and there's a key word. If you see reacting, you have got a chemical property. So let's look at the difference between a physical change and a chemical change. So we take all of the context that we've just looked at and we add something to it. So if we have a physical change, we often observe a change in size, shape, or state. And quite often we have that change in state, which is often mistaken for a chemical change. The other thing to note is we've created no new substance. On the other hand, if we've got a chemical change, we have a change in the physical and chemical properties of our substance being formed. So if we actually create water from hydrogen and oxygen, it has a different reactivity to the hydrogen and oxygen. It will also have different melting and boiling points to the original substances as well. So in this case, we've created a new substance. So the major difference is chemical change, we create a new substance. Physical change, we don't create a new substance. So let's look at three examples. If we have silver and it tarnishes, so it gets the oxidized layer, then we must have a chemical change. We've changed the physical properties. On the other hand, ice melting, we haven't actually changed the chemical properties, therefore it's a physical change. We haven't actually created or destroyed the matter. We've only changed its form. And that goes back to the change of state that we talked about earlier. If we have plants growing, on the other hand, plants utilise water and they utilise carbon dioxide to create simple sugars, and from their simple sugars they create more complex compounds. So that creation of new compounds tells us that we actually have a series of chemical changes within the plants as they grow.